Cool. Hi guys. My name is Srivalsan, a cloud architect from Amazon Web Services. Deal with containers, LLMs, MLOps. So I'll probably be covering there's quite a lot of buzz around LLMs for the last year and a half. So let's kind of put the DevOps flavor of how do we deploy LLMs in Kubernetes cluster using the framework. So I'm probably I'll be touching upon how we use Ray, how we use vLLMs. Have anyone heard of Ray? Cool, so that's going to be amazing then. So cool, and just a disclaimer, all of the opinions which I share is pretty much on my own. I don't represent my organization in any way possible. So cool, moving on, just before I kind of touch upon the LLMs, so probably I'm quite a strong advocate of platform engineering, and there's quite a lot of happening in platform engineering, but just want to kind of touch upon what do we do, why do we do platform engineering, and what we need to do right in terms of how do we build platform engineering. So moving on, I think there are quite a lot of things which happens in platform engineering, but essentially what we talk about as a platform engineering is that as an application developer, or as a person, or as a business analyst, or as a product owner, if you want to kind of build a simple proof of concept on applications, essentially they should kind of reach out to the platform engineering team, and the platform engineering team should only build reusable components and services which can be used by the development team to kind of provision those resources on a much more ClickOps way, which is essentially you kind of build the components and you have a particular developer portal. The one which I strongly advocate is Backstage, but there are quite a lot of other developer portals out there. And essentially, I think we should go towards the stage, as quite a lot of organizations are going towards the stage from moving away from DevOps to going towards the platform engineering, where you have a team which basically builds the platform, builds the components that are required for the platform, but not necessarily build infrastructure for the applications. I think as we grow scale in terms of running applications in cloud, it is not sustainable to kind of build infrastructure for applications, but rather enable the development team or application developers to kind of provision those resources for them, and you kind of provide those resources so that they can just come in and then build those applications for them. So you kind of hold the grail in terms of what resources needs to be provisioned in the platform, but you don't kind of build those infrastructure which is then provisioned automatically through things like developer portal. There's quite a lot of ambiguity in terms of how that kind of, so I kind of usually touch upon those in terms of my talk. So moving on. So we see quite a lot of applications built in LLM, and most of the times what tends to happen is they kind of go towards managed services, which is, I think someone kind of asked a question about SageMaker. So you have SageMaker, you have tool sets in Azure which kind of covers those things for you. But what we also see in terms of working with customers is that, so when you kind of go towards building applications in production scale, quite a lot of customers would want to kind of explore the possibility of how can I actually run applications, not just LLMs, even for data streaming apps, how do I basically run applications in Kubernetes cluster. So what Kubernetes amazingly supports is how do you run applications, is microservices-based applications, but the moment you kind of start running applications which are non-microservices-based applications. For example, if you just pick a Spark application, if you want to run a Spark application in Kubernetes, essentially Kubernetes does not, I mean, it does still support it, but pick a scenario where Spark expects 10 executors to run an application. Kubernetes tries to provision 10, and it figures out there's only 9 resources. So what Kubernetes scheduler does is it probably provides 9 executors to the service, and then says, I've got 9. When I have one more, I'll probably just give you one more. That's essentially how the Kubernetes scheduler kind of works, but which essentially does not work for a Spark application, because you kind of tune your Spark application to make sure that it is optimal for running with respect to 10 executor nodes. So that's why there are quite a lot of services there are quite a lot of frameworks which are right now available out there, which is specifically for particular applications. For example, for for streaming applications, you have something called as Volcano, which does quite a lot of things like bin pack algorithm, gang scheduling, which just makes sure that you only get the required resources to run those applications. One such framework for running ML applications is Ray. It's an open source framework which is specifically focused on running machine learning applications, and it has got quite a lot of components into it. I'm not going to kind of touch upon. So what Ray as a framework does is you can essentially deploy Ray in either cloud platforms or in Kubernetes clusters as well, and it essentially gives you a Ray core which has got all the computing frameworks which are required for you to kind of run the other libraries. So it has got multiple smaller components of libraries for data loading, for training the machine learning model, for like tuning the machine learning model, for serving the machine learning model, which is what I'm kind of going to touch upon in today's topic, which is how do you kind of serve LLM model so that it can then be consumed by applications. So it has got all of those components associated with it. And what Ray also kind of does is it essentially builds a cluster in itself, and then it has got its own framework in terms of running your machine learning models on top of the Ray framework. So if I have to just run across a stack of how a machine learning application platform would run is you would have your Hugging Face for your model registry, and then you will have be it PyTorch for basically building a framework. And then in my talk, what I'm going to touch upon is how do you kind of use vLLMs as a framework to kind of run your serve your machine learning models. And just to kind of touch upon that is also right now merged with PyTorch, so you could essentially say vLLMs is also kind of PyTorch. But then where Ray kind of comes in is where it how do you kind of orchestrate those machine learning models, and then you have the underlying GPUs, which is either provided by NVIDIA or other services around it. And then Ray kind of sits on top of the Kubernetes cluster, where it kind of helps you to serve the machine learning models. Now it comes down to the question of why do we need Ray to serve the machine learning models if we have other clusters? Why don't we kind of serve those in against Kubernetes cluster? What Ray essentially helps you to do is let's probably just move on to the next slide, which is you can quite essentially do seamless scaling. And when I talk about seamless scaling, there is a difference in terms of what do we mean by seamless scaling in terms of the applications, and what do we mean by seamless scaling in terms of the machine learning models. Because what you essentially would do is if you want to kind of host multiple models in a particular applications, there are certain models which requires a certain specific set of resources, for example. And you also can potentially explore the option of fractional GPUs, which is you have two models essentially using the same set of GPUs, or you basically use a particular percentage of CPUs to make sure that you kind of run your models efficiently. You talk about multi-model applications. You talk about how do you kind of compose multiple machine learning models into one particular application. So I think that's where Ray kind of sits in and make sure that you can actually run those efficiently. It's open. It's extensible. You can basically run this in any of the platforms because it's an open source framework. You can potentially run it in Kubernetes, Azure, AWS. You can essentially run it in all of those platforms as well. So just to kind of touch upon when I talk about multi-model applications, so what do we really mean by multi-model applications? And again, you use RayServe for serving the APIs. But if you want to kind of talk about how do we train or tune the APIs, then you have separate frameworks to kind of do that. And yeah, this is essentially how a Ray framework would look like. What it has is Ray has its own autoscaler, which kind of identifies how to basically scale the machine learning models in terms of the request which actually kind of comes in. And it has got its own Ray head node, which essentially you can actually look at it as if I have to just draw the parallels in terms of a Spark application, because Spark is quite famous out there. So you have the driver, which you can kind of correlate with the Ray head node, and then you have the Ray worker node, which essentially does all the scheduling and making sure the applications are provisioned. So this one is another extensive frameworks of how the Ray cluster components kind of look like. I'll probably just skip up and then move on to the next slide. And these are some of the few patterns in which how do you kind of run machine learning models, which is if you have a scenario where you kind of wanted to chain two machine learning models, or if you have a scenario where you wanted to basically do ensemble and chaining, which is you have to identify based on request which model you have to use to kind of get the inference from, and then use that to then do a chaining of the output model and then get the output. Or if you have a scenario where you talk about dynamic selection, based on the input, you have to dynamically decide which machine learning model kind of needs to be used. So I think these are some of the scenarios which you kind of use in terms of building applications, and that is where Ray would essentially help you in hosting these machine learning models in the right sets and making sure that the model kind of have the right access to the resources. I will kind of show you a Kubernetes YAML file which talks about how Ray can be configured and how we kind of use vLLMs against it. Now that's how the Ray kind of is used for the orchestration framework, which you can run on top of Kubernetes. But then when you talk about vLLM, what essentially we mean by vLLM? So probably a lot of people would have heard of PyTorch, and you've kind of used PyTorch. Where vLLM kind of differs from PyTorch is that, again, this is essentially the reason why we built, I'll also kind of show you a blueprint of how to run LLMs using RayServe and vLLMs, and this kind of came from a lot of customers' demand in terms of, can you guys tell me how to run an LLM from RayServe and vLLMs? And that's when we started exploring of why customers have asked for it. And vLLMs is essentially a paper which kind of came out, I think, September 2023, and the biggest advantage of vLLMs is that vLLM kind of introduces a concept called paged attention, which is if you want to kind of store the tensors in a key value format, which is essentially what machine learning models do. What vLLMs brought in is that you can actually store the key value formats in a non-continuous way, which you don't have to kind of store it on a continuous way as how essentially a lot of frameworks kind of does. That was quite a big change in terms of how you kind of store it, which immediately provides a high throughput and extensive memory usage in kind of running the machine learning models, and that's one of the reasons why we kind of touched upon how do you kind of use vLLM. So what essentially, on a quick nutshell, what it does is it has got your own logical key value blocks, which talks about, if you just take a prompt of 7 years ago, how our fathers brought what, and it basically then have a block table, and then it figures out how do you kind of store these on the GPU. So what this meant is that your memory management on the GPU level is quite efficient, which improved I think there's a paper which talks about how vLLM's performance against some of the transform models, and again, this is based on the paper. It says that the memory management is 55% efficient than the other transform models. So that's one of the reasons why I kind of picked up vLLMs as a concept to kind of see how do we provision, how do we run LLMs using Ray and vLLMs. Quick note is that vLLMs is right now merged with PyTorch, so it kind of still comes under the PyTorch umbrella in terms of running the machine learning model. So just to kind of quickly touch upon the rest of the ones, it does page attention, which I spoke about. It also does batching of incoming requests to make sure that the processing of the request can be handled on a parallel search and also on a beam search as well. And it also supports quantization using attention-aware quantization and GPT quantization as well. Quantization is essentially how do you kind of shrink your models in such a way that you can actually host your models in a much more smaller device. For example, essentially if you have to basically pick GPT-4 and then run it on our machines, it's never possible because it needs extensive GPUs. So quantization is a mechanism where you can efficiently pick and choose the salient weights to make sure that you can shrink and you can essentially run it on a much more smaller machine for efficient purposes. I think attention-aware quantization is a paper which kind of talks about if you identify the higher priority weights, which is the salient weight which is needed, and then you can actually run the model using 1% of the salient weights in a much more efficient way. And that's, so it kind of supports that, and then it also supports speculative decoding, which is again something which Google kind of started, which is essentially the model starts speculating what could be the decoding even before the decoding kind of actually happens. So it does support all of these frameworks as well. So that's one of the best things about vLLM compared to the rest of the other frameworks. So I will quickly take you through the blueprint, which I kind of spoke about. That's the QR code if you want to kind of access the blueprint. And sorry, I've just got it open. Yeah, so this is just to give you, so this is essentially a data on EKS blueprint, which I've kind of worked with few of the folks in Amazon. This is an open source one, which can potentially use it. It has got blueprints in running multiple applications, be it data streaming applications, be it LLM applications, essentially using EKS, but then you can potentially use this to see how we can actually run this applications using Kubernetes as well. So if I have to just quickly give you a walkthrough of this is a YAML file which kind of talks about how do you deploy a Ray service, which is of a kind. So I would then define the environment. So this is a blueprint where I kind of deploy the Mistral model which I kind of download from Hugging Face and then deploys it. So you can also see here the Ray cluster config where I define the head pods as I kind of spoke about in the architecture. And Ray also kind of gives you a dashboard where you can actually monitor the health of the application. So you do define the dashboard host, and you would essentially define the ports so that you can actually access those. And if I just scroll down, you would see that it also supports Grafana and Prometheus observability along with the Ray framework. And I am defining the worker group so that the services kind of run on the worker group. And also where I see here, I would define the vLLM port so that the applications, the machine learning models are hosted on that particular node. And I use Carpenter to make sure that the auto-scaling kind of happens. For people who don't know Carpenter, Carpenter is essentially a auto-scaling mechanism which is provided by EKS, which is used by EKS. It kind of works on an instance fleet level rather than on the node level. So essentially other horizontal autoscalers kind of build more vertical autoscalers build more resources based on the pods, but what it does is it kind of monitors on a much more instant fleet level so that when an instance is required, it is provisioned even before it is actually required. And you can also mention a set of instances which is required for you to provision. Doesn't mean that if you're running a T2 micro, the other autoscalers kind of only scale T2 micro level, but you can essentially tell Carpenter that you can give a bunch of instance type and then say, based on the load, probably you might need a much more bigger machine, or if you're running an M5 large, you probably might need a T2 micro to kind of serve the load. So that's essentially how when you can use Carpenter. And make sure to kind of, I think one of the best practice, make sure to kind of taint the node so that you so that you can make sure that your application kind of runs on the right node to access the GPUs wherever possible. Just to give you a quick view of the vLLM serve, this is essentially how you kind of load a vLLM, where you can see here you can define the tensor parallel size of how you want to kind of have it parallelized. And you can also define the sequence length and the number of sequences as well. Essentially over here, I'm defining the utilization, which is, I define saying that use only 80% of the GPU utilization, so that rest 20% is actually used in case there is an overhead of the GPUs. And so in the blueprint, if you see, Ray is used as a framework to host the LLMs, and it's basically served using the vLLM framework, and that's how you kind of run it on the Kubernetes cluster. The reason why we kind of touch upon this is because there's quite a lot of customers who are actually requesting how do we run applications using Kubernetes cluster, because then you're then quite easily integrated into the whole platform engineering model, which I kind of spoke about from the first, and then you can also start integrating towards your entire DevOps cycle, which is start using Argo CD to deploy LLM applications, and make sure that you bring in all the GitOps principle against it, which is I think the biggest challenge when we talk about right now in all the LLM applications is that how do we kind of productionize it? How do we make sure that these can be productionized, and then we can roll out features in a much more faster way? And also, how do we efficiently use the resources so that the cost to run LLMs or cost to run any machine learning models is down? So this way, there are a few customers that I've worked with where they have one big clusters where the microservice applications, your data streaming applications, and your machine learning applications kind of run on the same cluster, by efficiently using the infrastructure in the right way, and efficiently managing those infrastructures as well. So hope I'm right on time. Yeah, that's pretty much. Let me see. That's pretty much what I. Yeah, that's pretty much what I have. You can find this. Why is it not? Yeah, so you can find the blueprint in this particular, and there's quite a lot of blueprints out there. It's open source, so you can pretty much use you want. And that's my LinkedIn profile. Happy to take any questions if you